Hey guys, so in this video I wanted to do a video going over efficiency, and what I'm going to lead into is the efficiency of your subs and the coil, but I kind of wanted to go over just what efficiency is as a whole first, in kind of a way that hopefully you guys can understand more before I get into the sub. So efficiency is a loss of power due to heat. That means that as your amp or your alternator or your sub gets hotter and hotter and hotter due to heat, is going to actually create less power on your amp and less output from your subs. Something people don't think about. So in the last video I kind of went over how you might turn up the gain on your amplifier and try to get more output, but as a result you're going to clip the signal, which creates heat. And so actually what you're going to do is you're going to be heating up this coil that's inside your sub here, inside the gap, and as a result, even though your intentions are to get more and more output, because the coil is getting hotter and hotter and hotter, it's actually becoming less and less efficient. And so even though you're trying to get more output, you're actually defeating your purpose of running your amp harder, and you're actually going to lose output in your sub. But you're also going to lose output in your amplifier for a couple of reasons. So the first thing is, what's the difference in a 1 ohm stable amp and say a 2 ohm stable amp? And how is efficiency different between those two? So as I pointed out in the last video, to make 1000 RMS at a 1 ohm load, you would need 31.6 volts of clean AC power to actually produce that at a 1 ohm load. And the way that works is you have the two rails that I was talking about, and you get 31.6 times itself, and then you get this number here. And then depending on the impedance that you wire your subs to, 1 ohm, 2 ohm, 4 ohm, or whatever else you end up with, you divide your number here by the impedance that it's wired at. So at 1 ohm you get roughly 1000 watts, at 2 ohm roughly 500 watts, at 4 ohm roughly 250 watts. Now let's say, that would be an example, would be say a Sundown or a DC Audio amp would be a good example of a 1 ohm stable amp. Of course there's many other brands on the market, but those are some of your more common. So let's say that you had a 2 ohm stable amplifier like a Kicker or an Alpine that aren't 1 ohm stable, and that would also make 1000 watts, but make it at 2 ohm instead of 1 ohm. What's the difference? Well, in order for that same amplifier here to make the same 1000 RMS but a higher impedance, it would have to make 44.7 volts instead of 31.6. So doing the math here, you would see that the number you get is 1998, which is roughly 2000, but you're not running it at 1 ohm because it's not 1 ohm stable. So at 2 ohm you get 1000 watts, and then at 4 ohm you get 500 watts, twice what you got out of the 1 ohm stable. So this 2 ohm stable amp is technically making more power and more voltage than the 1 ohm stable amp, even though you're getting the same RMS of 1000 watts. And so this is why typically it's more affordable to run a 1 ohm stable amp, because technically it's not, they're not amplifying the signal quite as high, but so they can be more cost efficient most of the time. It all depends on where you're buying it and the brand you're buying and all that. But typically it's more affordable and easier to run at 1 ohm than at 2 ohm for the same amount of power. But the main difference here is efficiency. What are you losing in heat from efficiency by running at 1 ohm versus say 2 ohm? And so what it means when your amp is only 2 ohm stable or say 1 ohm stable, your amplifier, as I talked about in the last video, pulls in DC current off of a battery bank, a battery source, and the alt charges with an amperage charge to that battery, and then it'll have a charging voltage, like I said, around say 13.8 to 14.4 give or take, depending on the alternator, the kind of car you have, how old that alternator is, all that kind of stuff. But somewhere around 13.8 to say 14.4. And then that's going to supply to your battery, which is going to supply to your amplifier. And that's going to give you an idea of the voltage that you're going to be seeing in the power supply part of your amplifier. And so your amplifier, to make a given amount of power, is going to have a certain amount of amperage draw to make that power. And so if you had, say, a 1 ohm stable amp up here, and let's say that you were charging and sitting at 13.8 volts, if you divide this by 13.8, you get 72.36 amps of current draw. Now, this is if you were doing, say, a test tone and pulling a constant, non-stop, full power out of your amp, you may hit this number here. Now with music, because music's up and down and there's different levels of frequency and bass, you know, different points of which there's no bass, a lot of bass, whatever, your amperage draw, because your power output is going to constantly be changing, your impedance rise, the ohm low that you're going to be pulling at to get the certain power is going to change as you play music, which is going to affect the power you're putting out and thus affect the amperage draw. So on music, the true real-world amperage draw will be all over the place, but probably never max amperage draw. This is just worst case scenario at most. Now, thing is though, this is if you are at 100% efficiency amplifier, and there are no 100% efficient amplifiers. So let's say that you have a Class D 1 ohm stable amp and you're roughly 65% efficient. Now depending on the quality of amp you're running, if it's a Korean board amp, if it's a Chinese amp, the quality of the amplifier, what it's made of, how the board's laid out, your heat sink, all that kind of stuff is going to affect the efficiency of that amplifier. But let's say that you're 65% efficient. So that means that in order for your amp to produce, say, 1,000 RMS at 1 ohm, at 65% efficient, it actually has to be making 1,647 watts, and all you're going to see of that is 1,000. So 647 watts of what you're producing is being lost as heat because of efficiency. So actually, to make that 1,000 watts, you would be pulling 119.39 amps, again at full potential, full peak, to make that full 1,000 RMS at 1 ohm. Now a 2 ohm stable amp, again depending on the brand, the quality, where it's built, how it's built, will be more efficient, and say that it's roughly 80% efficient. So that means to make that same 1,000 RMS at 2 ohm, at 80% efficiency, it's pulling 1,248 watts and then giving you 1,000. So then you're only wasting 248 watts to heat versus 647, which means that you're only pulling a total of 90.49 amps to make that 1,000 watts at 2 ohm versus making 1,647 watts to make 1,000 watts at 1 ohm. So that's the difference in stability as far as efficiency goes for your amplifier. So that's why it's more efficient and better on your electrical, because when you're pulling less amps, there's less demand on your battery bank, there's less demand on your alternator, because your amp's running more efficient for that same level of power, but it's going to typically cost you more money to make the same power at a higher impedance. So that's the trade-off. You save money at a 1 ohm load, and then you can theoretically get more power for your money, but at the cost of efficiency and heat. So as long as you can keep your voltage up higher, and you have the right amperage to handle your current draw and all that, 1 ohm could be the way to go. Now also, 1 ohm, 2 ohm, 4 ohm is going to affect dampening, which is control over the sub, and that's going to be just how accurate your amplifier on the rails and the positive negative will kind of act like brakes, and actually it'll give control over that sub as it's playing. And so 1 ohm is a lot more power, but it's a lot less control over your sub. So I mean, that's going to depend on, you know, are you just playing lower end rap, or are you playing a lot more detailed music? That'll play in a lot more of that. But more so is your enclosure is going to play the biggest role in how your sub's going to perform, how it's going to sound, how it's going to hit. All that is going to be in the box primarily. But getting technical, the impedance that you run at will also play a role in that, as well as efficiency. So what that means for your amplifier is that the reason why, say, you know, the amp is 1 ohm stable is because your amp, the power supply and the circuit board itself in here that is converting and then putting out your AC voltage here is only they're built for a certain amount of current draw to come into this amp. And if you run it too low of an impedance, say that you're at 1/2 ohm, or that, you know, you don't have the electrical here to back up the current draw, you're going to put a lot of resistance, heat into your power supply, and it's going to cause it to get hot, possibly burn up. And so if your amp is trying to process and convert and stuff and boost this AC voltage to a higher level, and you're simply trying to draw too much power, too much current through this amplifier, is gonna get hot. That's what efficiency is. And that can cause that amp to fail, to blow. You can melt your, you know, positive, primarily your ground block. That can melt, that can fray, your wires can melt, whatever, because you're trying to draw more power. That's why if you had, say, a 2 ohm stable amp, you know, the reason why it can't run at 1 ohm and produce, say, 2000 RMS at 1 ohm is because the board and the power supply are not built and are not made to handle that kind of current draw into the power supply and across the board. It just wasn't manufactured for that. And so that's why some people like to run, say, a 1 ohm stable amp at, say, 1/2 ohm, but at 1/2 ohm, you wouldn't get 2000 RMS because you're running half the impedance. See here how you go from 250, 500, 1000. If you were at 1/2 ohm, you wouldn't get 2000 RMS, and the main reason why is because of efficiency. You would get over 1000 RMS if your amp can handle one being ran at a 1/2 ohm, and if you have the electrical to back that up. But you wouldn't get a whole lot more power out of your amplifier, because at that point it begins to fall off in efficiency drastically, and at that point you're really testing your amp's quality, if it can handle it or not. And so something that happens is, so far this has all been 1-channel amps that I'm talking about. Well, there's amps that are 2-channel, and if you were to bridge a 2-channel amp, usually they're only stable at 4 ohm. And so the same thing goes there. If you bridge your 2-channel amplifier, you can't run it below 4 ohm bridge, not at 2 ohm, especially not at 1 ohm, because there again, at that point, you're trying to draw more current through the amplifier than it was designed and built to do, and that's pretty common. But, so going on to your subs. So as I talked about, when you clip your subs and you generate a lot of heat from a clipped signal, the coil in your sub is rather small, and it's a smaller gauge. And so looking inside this motor here, if you can imagine, it's a round motor obviously, and in here there's a pole in the middle, and then there's a gap, and then inside this gap is your coil. And that coil is a very tightly round, smaller gauge wire, and the leads run out to here, you know, on the sides. This is a dual 4, so then 2 ohm, this is 4 ohm hookup, 4 ohm hookup. So it's access to each coil on each side of the sub here. And so, you know, you can wire that sub in a parallel to 2 ohm or in series to 8 ohm. And so you're passing your power through your connections into that coil. And that coil is very small, and if you have a lot of excess heat because you're trying to push the sub too hard, trying to make up for what the box isn't giving you, like I've talked about in the past, that coil is going to heat up, get hot, possibly start smoking, possibly fall apart. Your leads and stuff in here that are connecting you from your connections to the coil itself, to the former, they can melt, fray, break, whatever. And that's simply because of heat. And there again, if you get this coil hot enough, you're actually gonna begin to lose efficiency and thus output out of your sub, as well as your amplifier getting really hot, because the hotter your amp is getting, the less power it's gonna make. The hotter that your alt gets, the less amperage it's going to supply to your battery, that it's going to be sent into your amp, the less power your amp's going to make, and then it's going to get hotter, it's going to make even less power, which is going to lead into a clipped signal, which is going to lead to your sub getting hot, getting clipped, getting distorted. It's a downward spiral. So the point is here is everything about your system, especially efficiency in what you're running, what you're trying to do, how you're trying to get there, all of that plays together and is very important when you're trying to reach a certain output, a certain goal. So there again, you don't just turn up your amplifier and just push things to their breaking point to get that extra output and to get louder, because in the end you'll actually be hurting yourself and defeating what you're trying to do, and you're going to end up hurting an amp, alternator, subwoofer, whatever.